Okay, so let's look at this subtopic here. Okay, so transfers of thermal energy. So as you can see here, we have conductors. Okay, conductors. So conductors, of course, you know that they can conduct electricity. They are like metal. Okay, first point, good conductors are used whenever heat is required to travel quickly through something. Okay, so we want heat to travel quickly in, for example, the cooking pot. A cooking pot, you want the food to be heated up quickly, so we need to use good conductor. So that's why the cooking pot is made of metal. Bad conductors, like insulators, are used to reduce the amount of heat lost to the surroundings. So for example, paper cup or polystyrene cup. So they are bad conductors. So because of that, the heat from our drink doesn't lose easily to the surroundings. So they can keep the drinks to remain hot. Okay, so conductions. Conductions is the flow of heat through metal from places of high temperature to places of lower temperature without movement of the metal as a whole. So that means you can just hold the whole thing. You can hold the metals. You can hold the metals like that in stationary. No need to move it. You heat it at one side. So what happens is this part becomes hot. So it becomes hot basically because you are burning it okay, through by using the candle here. And what happens to the metal is vibrations happens. Vibrations of the ions, the metal ions, vibration of the electrons happens. So we focus on the vibrations of electrons. So the vibrations of electrons is spread throughout the metals. You know, metals have delocalized electrons. So the vibrations of electrons happens quickly and the energy are spread to the hand and the hand feel hot. Okay, so that's what happened to the metal. So the important point here is we need to remember metals, the vibration of electrons causes the heat to be transferred through conduction. Vibrations of electron is the main method used to transfer the heat through conductions. So let's see non-metal. In non-metal, when heat is applied to something, its atoms vibrate faster and pass on their vibration to the adjacent atoms. So that means the main concept here is for non-metal, it is the vibrations of atoms. Vibrations of atoms that causes heat to transfer through conductions. When you compare metals and non-metals, you can easily see that metals, they use vibrations of electrons. Electron is light. You can make it vibrate easily because this is small, little, tiny, and light electrons. You want it to vibrate, it can easily happen. So because of that, metals is a good conductors, okay, because of the electrons. Non-metal, it is the vibrations of atoms that causes the conductions of heat. But atoms is much more heavier compared to electrons. So because of that, the conductivity of heat is kind of poor in non-metal because atoms is heavier. Okay, so now you see this point. In metal, conduction happens in the previous way and in a quicker way. Electrons are free to move. They travel randomly in the metal and collide with atoms and pass on the vibration. So vibrations of electrons happens and pass on the vibrations to other electrons, and hence it can conduct heat quickly. So that is conduction. So we have done conductions. Conduction is about the vibrations of the atoms or the electrons. Okay, now we see convections. Convection is the flow of heat through a fluid. So when I say a fluid, right? So the fluid here refer to liquid or gas. Liquid or gas. From places of higher temperature in places of lower temperature by movement of the fluid itself. So the fluid move, not like conduction. You see, conduction just now they said without movement of the metal as a whole, this thing doesn't move. The solid doesn't move, remains stationary, and the conductions of heat can happen. But convections, the fluid, the liquid and gas is moving around. Okay, so that's the difference. Doesn't move, but this one move. Okay, so how it move? Basically, you can see this picture and understand it. You heat up this particular part, then it becomes hot at these regions. Then the hot water, the warm water rises because it is less dense. And then they come here, and then after that, form a flow. Okay? The cold one will come and replace the water that rise up. So because of that, it forms a flow. That is convections. So as a fluid, liquid or gas warms up, so here, the particles which are warmer become less dense and rise. So which is here, goes up. Then the then cool and fall back to the heat source. So they go up and then they cool down again. I mean, they rises up and then it cools down and then it drops back to the source. Okay? So they form a cycle. Creating a cycle called convection current. So convection current is the flow of the fluid, not the flow of the electricity. So although it's current, current doesn't mean electricity all the time. So it can be the flow of the fluid. So as particles circulate, they transfer energy to other particles. So this is circulate. Just now, this one is vibrate. Circulate and vibrate. Okay, so you can see some important keyword use. Circulate. And you can see movement of fluid. Movement of fluid. Compared to this one is without movement of the metal. So you can see some important point over here and the important terms that we use here. So as particles circulate, they transfer energy to other particles. If a cooling object is above a fluid, it will create a convection current. So you want convection current to be created. That is a condition. The condition is the cold one must stay on top. The cold one stay on top. The problem is it is heavy. So it's heavy and it will fall down. So it will fall down and then it creates a convection current. So one of the important application is one of the example is the aircon. So aircon we used to put on top of the room. Okay, aircon. So the aircon has cold air. So the cold air is heavier. Cold air will flow down. Okay? Then the hot air will go up and then go into the aircon, and it creates convection current. Another example is heater. Heater, of course, is used in cold country during winter. So they put a heater on the floor. Okay, heater, they put heater on the floor. So heater creates hot air. So the hot air will go up. Okay, so go up because it is less dense and it rises, and then creating a convection current. The cold air will come down because it's heavy. Cold air come down and then go into the heater to be heated up, and then the hot air will come out again. So it creates convection current again. So we need to put our aircon and the heater at a proper place, so that convection current is formed.
So basically the hot air is always on the top. The hot air always rises.
Always rises, yes, correct.
And the hot air is less dense than the cold air.
Yes, true. Yeah.
So the cold air is always the heaviest compared to the hot air.
Yes. So the cold air will just sink to the bottom. Yeah.
Okay, understand.
Okay, so now let's look at the next page then. Okay, so on this page you have radiation. Radiation. So radiation is the third method for the heat to transfer. The first way is conduction, second way is convection, now the third way, radiations. Okay, radiation. So let's look at radiation. The first point here. Radiation is the flow of heat from one place to another by means of electromagnetic wave. So this point is important. Electromagnetic wave brings energy, bring heat to other place. So, conduction just now, vibrations of electron or vibrations of atoms. Convection is the circulation of the hot air and the cold air, or circulation of the hot liquid and the cold liquid. Okay, but radiation is the electromagnetic wave that brings the heat to other places. So for example, the sun heat up the earth because it brings the heat energy through the sunlight. So the sunlight is the electromagnetic wave. Okay, so the sunlight reach the earth and heat up the earth. So the idea is like that. Thermal radiation is mainly infrared wave. Infrared wave. So, electromagnetic wave, there are many types. How many types are there? So we do a quick revision. We have M is useful when no gambling. Okay, it's a special sentence to remember the electromagnetic wave. So R stands for radio wave. M stands for microwave. Is infrared. Useful. This is it's very useful. It's very useful. Okay, so very is means out. The very is visible light, and then the useful stand for ultraviolet. When no stand for X-ray. Gambling stand for gamma ray. gamma ray. So this is the kind of, or the types of electromagnetic wave. Out of all these, right? So infrared carry heat, carry a lot of heat. So visible light, of course, carries the light so that we can see brightness. Ultraviolet is carried also from the sunlight. So it's one of the famous thing. Ultraviolet make the skin getting skin cancer, for example. So it's because of the UV light. So our main concern is how the heat is transferred. So through infrared radiation. So infrared wave or infrared radiations. But very hot objects also give out light wave. Infrared radiation is part of the electromagnetic spectrum. So these are the spectrum. So heat is transferred through infrared. Okay. So of course the sunlight give us visible light as well. Okay, we need to know that. And visible light is also electromagnetic wave. Okay, so and radiations can be transferred through vacuum. Okay, so it doesn't need to have solid or fluid as in conduction and convection. We don't need that. It can transfer through vacuum. So that's why, although there is no air in between, the sunlight can reach the earth. Okay, now, of course, sound cannot. Sound cannot transfer through vacuum. Just for comparison. So that's why you can't hear any sound from the sun. So it seems to be very quiet. The sun is very quiet because it is vacuum in between. So that's why the sound from the sun cannot transfer to the earth. Okay. We hear no sound from the sun. Okay. Now we look at the table here: emitter, reflector, and absorber. So we have three term. It's very popular in exam questions. Basically, I had to tell you, very popular. So what is emitter? So emitter is the one that release heat. And emitter sends out thermal radiation, release heat. Emitter. Okay. So what kind of material can be the best emitter? It is matte black. Matte means not shiny. So the black color object that is not shiny is the best emitter. It can release heat to the surrounding at the highest rate compared to other color object. So one of the example that I can give is like, black car in winter, it become cold. Okay, become cold quickly compared to silver car. And of course, black car will be very hot also in the summer place, like, or hot place. Okay, in hot place it will be very hot, but in winter it will be very cold because it is the best emitter. Okay, so white, moderate, silver, worse. So imagine you're driving a silver car in the winter, so it doesn't release the heat easily because it's the worst emitter. So it is warm compared to the black car. Okay, so likewise, if you are wearing black shirt, so you will feel cold in winter. But if you are wearing shiny shirt, so not so cold. Okay, so reflector. Reflector, of course, from the words reflect, So the heat reach the object and then is reflected away. Reflected. Okay? So if if you can reflect, then the heat will go away. If it can't reflect, then the heat will enter the object. So this is the object. Okay, now let's see. Matte black is the worst reflector. So you want the light, you want the heat to be reflected. It is very hard for the black color object. If it doesn't reflect, that means what? That means it will absorb the heat as well as the light actually. So that's why black color is the worst reflector, and hence it will be very hot. If you supply heat to it, it becomes very hot. So very extreme one. That means this matte black is very extreme. You make it hot, it becomes very hot. You make it cold, it becomes very cold. Okay, because it's the worst reflector. It cannot reflect the heat away, so it will just absorb the heat. White is moderate. Silver is the best reflector. That's why silver, you found it shiny, so because the light, the heat is reflected. So one of the very popular application for reflector is the thermos. You see our thermos, right? Inside the thermos is silver color. Okay, let's say this is the thermos. So this particular region, the inner surface, is made of silver color. Silver color is the best reflector. So when you pour in hot water, put hot water here, so the heat come here to the silver surface, then it's reflected. The heat is reflected and remain in the thermos. Now they move until here, then it's reflected again. So the heat remains in the thermos. So the water remains hot because they are using silver surface. So reflection happens. Okay, then absorber. Who is the best absorber? Is the matte black absorber. So you put this matte black object under the hot sun, so it will absorb the heat. It will absorb a lot of heat, so it becomes very hot. Okay, so white, moderate, and then silver is the worst absorber. Okay, now you have to memorize who is the best, who is the worst, so must memorize it. Okay, we look at this point. An emitter sends out thermal radiations. A reflector reflects thermal radiations, therefore is a bad absorber. So you see these two are opposite. If it's the best absorber, then it's the worst. If it is the best reflector, then it's the worst absorber, and the other way around. Okay, so it's opposite. Okay, so an emitter will cool down quickly because emitter will release heat, release heat to the surrounding and become cold. An absorber will heat up more quickly. Okay, and a reflector will not heat up quickly. Reflector will make the heat bend and go away, so it doesn't heat up. Okay, so a lot of application. We will see that later. Let us finish up first. Applications of energy transfer. The first point, solar panel. The sun's thermal radiation is absorbed by a matte black surface. So if you see that before, so you should know that solar panel is black color and warms up the pipes containing water. Okay, so that is how the solar panel is used to heat up the water. It's matte black because matte black is basically the best absorber that will absorb the sunlight a lot. Refrigerator, the freezer compartment is located at the top of the refrigerator. The freezer compartment, the part that we put ice. It cools down the air which then sinks. So the air release and sink to the bottom. Any warm air rises to the top and then it's cold. This creates a convection current which maintains a cold temperature. So try to imagine what happened in refrigerator and try to understand why you have to put the freezing compartment on top, because cold air will, after the freezing compartment has made the air cold, then the cold air can sink to the bottom and make the lower part cool down also. Okay, now third point, metal used in cooking pans because they conduct heat well. Okay, so conduction, application of conduction. So you can see this first application is the radiations application. The second one is the convections. The third one is conductions. So they give one application each. Consequences of energy transfer. Metal spoon in a hot drink will warm up because it conducts heat. So the metal spoon become hot. Convection current create sea breezes. Okay? So that means the wind blowing from the sea. Okay? Wind blowing from the sea, and when does it happen? So we need to know that. During the day, the land is warmer. During daytime, the land is warmer because you can heat up the sand quickly, but you cannot heat up the sea water quickly. So the land become hot, become warmer, and act as heat source. Okay, so imagine, let's say this is the land, and here is the sea. So during daytime, the sun is shining. The water, the sea water, will heat up slowly. But the land, which is made of sand, mud, they will heat up quickly. So here become hot, and then the hot air rises. And here has no more air after the hot air rises. So because of that, this part which is cold, you have the movement of air to the land. So the movement of air in this particular way is called sea breeze. That means the wind from the sea happens during daytime. Okay? And then during the night, the sea acts as the heat source. Okay, so during night time, we need to know the land will cool down quickly, but the sea remain warmer compared to the land because it has high specific heat capacity, right? So it has a lot of heat inside, so it remain warm. So because of that, something opposite happen. So let's say this is the sea. The sea is here. So the hot air will rise from this side and making this region to be empty, no more air. So then the air which is cold from the land will just flow from the land to the sea. So we call this land breeze. Land breeze. Okay, so the wind flow in that direction. Okay, now next one. A black saucepan cools better than a white one. Okay? A black saucepan, because it is the best emitter. So it releases a lot of heat quickly compared to the white one.
It's also best heat absorber.
Best absorber. So absorber, we use this point when you want to heat it up. So you want to heat it up, the black saucepan can heat it up quickly because it's the best absorber. So it absorbs heat quickly and heat up the food quickly. Then white houses stay cooler than dark ones. White houses. So you paint your house white. So what happens is white is white or silver lah, no? Okay, white or silver is the best reflector. So they reflect the heat from the sunlight, and then the house remains cold. Okay, if you paint your house to be black, so maybe you will regret because during daytime it becomes very hot. Okay, it's the best absorber. Okay, so we have done everything in the theory part. Okay, so now let's go through some questions regarding to this subtopic. Okay, so we'll go through some questions together. So let's look at this. Figure 3.1 shows a metal plate warmer. Okay, so you can see this. It's just to keep the food warm. And let's see the design. They put candle at the bottom. And here they put the metal warming tray. They put the food on top, handle at the side. Okay, the plates warmer contain two small candle heaters. Plates of food are placed on top of the warming tray. So buffet, in buffet you may see this. A part 1. State the name of a process by which the thermal energy from the candle passes to the warming tray. So how the heat go up to the tray? So
Can I put conduction?
You have three choices: conduction, convection, and radiation. Conduction, they don't accept because pass to the warming tray. Pass to the warming tray. So imagine this is the candle. The warming tray is up there. The heat is from here. How they can transfer to the tray up there? So in this part, conduction happen when the heat reach here, and then conduction on the tray. On the tray itself, that is conduction as the methods of heat transfer. But these regions, which is air, okay, so you can say convections. Convections, the hot air will go up. Convection. Even radiation, the accept also radiation. Okay, so the infrared will transfer the heat here. So convection or radiation. Conduction happen when they reach here. When the heat reach here, conduction happen along the tray. Okay, part 2, state the name of the process by which thermal energy move through the warming tray. So this is the moving through the warming tray. This is the solid. This one is what we discussed just now. When they reach here, the heat move around by using conduction. So the answer is conduction. Okay, now we look at B. The outside of the plate's warmer is shiny.
I still don't understand A2.
A2.
Yeah.
A2 is move through the warming tray. That means when the heat reach here, how they move along the tray. How the heat move along the tray. You look at the blue one. Along the tray. And you have to know this is a solid. The warming tray is a solid. So heat transfer through conductions in solid. So that's why conduction is acceptable there because it's a solid. So this part is part 1. A part 1 is here. Then A part 2 is here. So I use two different colors to separate between part 1 and part 2. So part 1 is the air. Part 2 is the solid. So for A, you either say convection or radiation, the F-set. For solid, conduction. Okay. Now we look at B then. Okay. For B, the outside of the plate warmer is shiny. So this part is shiny. Okay, shiny. Suggest how this helps the plate warmer to stay hot. Okay, so shiny, if you still remember the properties, let's take a quick look again. Shiny, worst emitter, best reflector, worst absorber. And that is the shiny surface. Okay, so
it's a best reflector.
yeah. Okay, so you can say it's the best reflector. Then reflect light. Or the wave, reflect light or wave to the food. Okay. Now,
Can I reflect heat to the food?
yeah, like heat to the food. Okay. Okay, that's it. The handles of the plates warmer are made from metal. So this part, make of metal. Identify a problem with these and suggest how the problem could be solved. So the problem is the handle will become hot. We don't want the handle to be hot. It's useless, So we want the food to be hot. The handle is getting hot and it doesn't really necessary, So the problem is handles become hot. The heat energy go to the wrong place at the end. So we want the heat energy to come here. We don't want it to be there. So how to overcome this? Use an insulator.
Insulate the, like cover the.
Yeah, like plastic.
With plastic.
And you can cover it with plastic, or you just don't use metal handle, use plastic handle straight away. So it overcome the problem. Okay. Now, let's see this again. Especially the conduction, convection, radiation, as well as emitter, absorber, and reflector. So 6 of these things sometimes make people confused a bit. So we need to see more questions on this. Okay, so let's look at the next page. Okay, so we are going to discuss through question on the right-hand side. Researchers have found that the best temperature for drinking coffee is 60 degrees Celsius. A designer has developed a new types of cup for keeping coffee at 60 degrees Celsius. The cup is shown in figure 8.1. So let's take a look. Plastic lid, coffee here, material Z, seems like black color. Oh no, it's not. Inner steel walls. So it's steel. Inner steel wall. Shiny outer steel wall. Okay. So material Z has a melting point of 60 degrees Celsius. At room temperature, material Z is solid. So you feel like this material Z are the unknown material, having a melting point which is same with the temperature that we plan to have, 60 degrees Celsius. We want the coffee to remain at 60 degrees Celsius and material Z as melting point at this temperature. So we need to think how it helps. Okay, so coffee at a temperature of 90 degrees Celsius is poured into the cup. So this is kind of normal, when you make coffee, you put boiling water and the coffee have a very high temperature initially.
Sir, I have a question. When they say material Z has a melting point of 60 degrees Celsius,
Okay.
if they put a very very hot coffee, let's say 80 degrees Celsius, so the material Z can melt.
Yeah, it melts.
Okay.
You put 90 degrees Celsius coffee, of course it melts. It melts. Okay, so we have to see what will happen. Of course, it melts and it doesn't release to the coffee. Okay, so it just melt and it remain here, remain in this black color regions. It doesn't melt and go into the coffee and you drink coffee with material Z. Oh no, we don't want that. We just want coffee. We don't want the material Z. Okay, so it is related to our graph actually. You see, we discussed this graph before. Temperature,
Yes, sir.
time. So like this, like this, like this, like this, and like that. Okay, so we talk about this particular region, 60 degree, 60 degrees Celsius. So this is where the material Z melt, or in other words, freeze, freeze or melt. So it's the melting point. So we want to see how it helps afterwards. So this graph will give you some idea of course. So how we see later. Let's see what they ask first. State what happens to material Z when the hot coffee is poured into the cup. So of course it melts, right? So material Z melts. So when it melts, what happens is the material Z is initially at room temperature. Imagine that. Because you just put it at room temperature. Then after that, you pour in the hot coffee. The material Z will have increase of temperature. And then after that, what happens is start to melt. When it start to melt, it absorb the heat from the coffee. That's the thing. It absorbs heat from the coffee. So the coffee loses heat and become cold. Okay, so it will cool down the coffee to 60 degrees Celsius. Okay, and materials that will use the energy from the coffee to go through the melting process. And of course, the melting process will make it remain at 60 degrees Celsius. And it makes the coffee become 60 degrees Celsius also. So that is how it helps. Okay, now let's see B. Explain how the features of the cup enable the coffee to be kept at 60 degrees Celsius for a long time. Plastic lid. Plastic insulator. So this is a good
Heat reflector.
heat reflector.
Oh,
Reflector depends on the color. Either they are matte black, white, or silver. Okay, so if it's silver, then it reflects. So they never say this plastic is what
but
kind of color.
isn't it that the plastics naturally like won't let the heat to? It will like trap the heat.
Yes, it 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 traps the heat basically because it's a poor conductor or a good insulator. So that's why they expect us to write good insulator rather than saying reflector because they never mention any color of this. So if they say shiny, like silver color, okay, yes, you can say reflector. But when they never mention about the surface color, don't say absorber, reflector, or emitter. Okay, just say conductor or insulator will be fine. Now the next one, vacuum. Vacuum will prevent. You see vacuum layers is here. Prevent heat loss through convection. You know, convection, they need the circulation of fluid. So with vacuum here, circulation of fluid cannot happen. No fluid available for circulation. Next one, shiny outer steel wall. So it's the shiny, this shiny will lead us to reflector or emitter. Okay, so shiny outer steel wall. So what we can put here is for this shiny silver, you can say it is a good reflector. Okay, good reflector, or you can also say it is a bad emitter. Bad emitter. Shiny surface is a bad emitter. It doesn't release heat to the surrounding. So, okay, bad emitter. Okay. Now let's continue. Material Z. Okay. So material Z, you see, this is a 5-mark question. So you get 1 mark, 2 mark, 3 marks. Material Z. Okay, so let's talk about 2 points for this. Okay, so how to explain that? You say at 60 degrees Celsius. At 60 degrees Celsius. Yes. Yeah.
So I just have to put like plastic lid is a good insulator. That's all. I don't have to like explain, like give another point for like explanation and all that. Must I do that?
If you explain further, of course, you may get the second point. The second point, the marks is given in this way. If you put 2 points here, then this one will be 1 point, 1 point, and 1 point. So it's flexible. If you can explain more on plastic lid, just go ahead. You get 2 points, then the rest you get 1 point. Or you just say this to get 1 point, 1 point, 1 point, then this one you can put 2 points.
Oh, okay. So.
Yeah, it's flexible. Okay, so at 60 degrees Celsius, material Z melts. You know, during melting process, the temperature remain the same. So we explain that. Material Z maintain constant temperature of 60 degrees Celsius during melting. Okay, so that's how we pull it. Okay, now let's look at another one. And this is a very popular question, so it's good to see. Let's see one more. Okay, we look at the questions on the right here. Number 5. two pans containing water are placed on the hot plates of an electric cooker as shown in figure 5.1. So you can see small pan and the large pans. The hot plates are switched on and the temperature of the water in the pan starts to increase. When the temperature of water is below 100 degrees Celsius, some water is evaporating. At 100 degrees Celsius, the water starts to boil and its temperature remains constant. And then state and explain which pan has the greater rates of evaporations of water when both pans of water are at the same temperature. So you look at the picture and you think about it. Which one will evaporate? Yeah, the last one. Okay, so large.
Because it has a just
Cause
it has a large surface area.
yes, correct. Because it has a large surface area. That is the keyword for evaporation. You have to link with the surface area. Now we look at B. Apart from the temperature at which it occurs, state how boiling differs from evaporations. Apart of temperature, so temperature for boiling is 100, evaporation is below 100. So apart from temperature, any other difference? So we have to say out just one difference. So for example, you can say evaporation happens on the surface, boiling occurs throughout the liquid. So that is one of the common answer. So boiling occurs throughout the liquid, while evaporation occurs on the surface of liquid. Okay, then we look at C. When the water is boiling, thermal energy is being supplied to the water at a rate of 920 watt. Okay, so the heat, the electricity supply this power. Explain the effect on the molecules of the thermal energy supplied. So the effect on the molecules. Okay, so boiling, right, is where the intermolecular forces are broken. It's where the liquid molecules change to gas molecules. So gas molecules, they are further apart. So this one should be easier to answer. First, you can say the molecules separate. Second, you can say about the intermolecular forces. Intermolecular forces are broken. Okay, so that's how we handle it. Okay, now let's look at the next part.
Sir, I still don't understand question C1. Can you explain?
Okay. You see the question again. Explain the effect on the molecules. What happens to the molecules when thermal energy is supplied to the water to make the water boil?
Oh, so the thermal energy supplied is what making the water boil.
Yeah,
So it can be like from a water from the heater and all that lah.
yeah, heater. So during boiling, what happened to the molecules?
Oh, okay. Understand, sir.
Separate molecules has intermolecular forces to be broken.
Oh,
Now,
so
let's continue with
let's say if like there's boiling water, so the water um the each H2O molecule will break off. The van der Waals force will break off.
yeah, the van der Waals force on hydrogen bonds. So break off and separate and become steam. So that is simplified in these words.
Okay.
Separate
So, sir,
and simplify as intermolecular bonds. Yeah.
I'm just curious.
Okay.
Let's say we boil the water. We boil water, and it's already 100 It's already more than 100 degrees Celsius. So eventually, the water will evaporate, right? The
If
boiling
the
water.
temperature is more than 100, it's already steam. So it's already steam. So it's not in the kettle anymore already.
Oh, so when it becomes steam, then it won't. The process is not called evaporation, right?
More than 100. More than, you have to know that boiling happen at 100 degrees Celsius. More than 100 is just the steam become hotter and hotter. It's not boiling or evaporation already.
So evaporation, let's say we dry a wet cloth outside. So evaporation will happen at all sorts of temperature,
Yes, correct.
depending on the humidity and all that stuff.
Yeah, that are the factors.
Okay,
So
so
the temperature for evaporations to occurs is below the boiling point.
okay,
Below the boiling point. Okay.
understand.
Now let's see part 2. The specific latent heat of vaporization of water is 2.3 times 10 to the power 6 joule per kg. Okay. Now, remember we use this during the boiling of water, and you have to remember the corresponding formula, which is Q equal to ml. Okay, calculate the mass of water that boils away in 5.0 minutes. 5.0 minutes. Okay, so you boil the water by using this power, 920 watt. Okay, so you have to know that the Q here is the heat energy. So the heat energy is power multiplied with time. Power multiplied with time equal to mass times latent heat of evaporation. So we are looking for the mass. Power is 920. For time, 5 minutes means 5 times 60 equal to 300 seconds. We have to use the SI unit. So 300 seconds. The mass is unknown. The L is 2.3 times 10 power 6. Okay, then we just rearrange and count, then we get 0.12 kg. Okay, so this is the amount of water that boils in 5 minutes. So you see
So
the
can I
use boils.
why you put power and time?
That is the formula actually. I am not sure whether you know it in this way or not. Normally we understand power in this way. Power is energy over time. Normally, we understand power as energy over time. Then you put the time to the left, right? So power multiplied with time is equal to energy.
So we're using power, we're using PT equals to M, and the specific lantern heat is because of the pans are electric cookers. Isn't it like that?
Yes, electric cooker. Then you change the Q to power and time.
Okay, sir.
So the electric device, they always tell us the power. They always tell us the power. So we can easily get that. Yeah.
Can I also know the uh, the unit for power for, is it watts?
This is what.
So don't have to change it to kilowatts or
Change it to kilowatts for electricity bill. For normal use, we use watt.
so for this chapter it's in watt.
Yes.
Okay, sir.
Okay. So that's
So
done.
for the chapter electricity we must use kilowatt.
Uh, Not the whole chapter. We use kilowatt if they want us to count the electric bill, but it doesn't happen. It doesn't happen. So that means we are still using watt in electricity chapters. Okay.
Okay, sir.
So we have done everything in this chapter.